Let us do the problem. Find two consecutive positive odd integers. Sum of whose squares is 290. Okay. Solution. Since the required numbers are consecutive positive odd integers, let the numbers be x and x plus 2. Let the numbers let the numbers be x and x plus 2. Okay. Since the required numbers are consecutive positive odd integers, let the numbers be x and x plus 2. You just observe the problem. Sum of whose squares is 290. This means what? The sum of the squares of these two numbers, that is x and x plus 2. The sum of the squares of x and x plus 2 is equal to 290. That's all. Therefore, which implies according to given. Therefore, according to given, x square plus x plus 2 whole square is equal to 290. Okay, this is because of the given. Because you see here, sum of squares is 290 means what? The sum of the squares of the required numbers is equal to 290. Okay, here you can utilize a plus b whole square formula. We know that a plus b whole square is equal to a square plus b square plus 2ab. So by using this formula, you just expand this one. That's all. By using this particular formula, you just expand this. Okay. Therefore, the above equation implies x square plus x square plus 2 square plus 2 into x into 2, which is equal to 290, which implies x square plus x square 2x square plus 4 plus 2 into x into 2 4x, take 290 this side, minus 290 is equal to 0, which implies 2x square plus 4x plus 4 minus 290 minus 286 is equal to 0. So dividing throughout by 2 means what? We have to divide each and every term by 2, which implies x square, that is 2x square by 2, x square plus 4x by 2, 2x minus 286 by 2, 143 is equal to 0. You see, this is the quadratic equation in x. This is the quadratic equation in x. Okay, the standard form is given by what? Ax square plus bx plus c is equal to 0. Okay, this is quadratic equation in x. This is the standard form of the quadratic equation. By comparing these two, we have what? The values of a is equal to 1, b is equal to 2, c is equal to minus 143. Okay? By comparing these two, that is quadratic equation in x and the standard form of the quadratic equation, we have the values of a, b and c. A is equal to 1, b is equal to 2, c is equal to 1 minus 143. Okay? We know that. We know that x is equal to minus b plus or minus root of b square minus 4ac by 2a. This is the quadratic formula. By using this quadratic formula, we can find out the roots of this quadratic equation. Roots of this quadratic equation, in other words, zeros of this quadratic equation. In other words, the values of x of this particular quadratic equation. Okay, let us substitute the values of a, b, and c. Okay, minus the value of b is what? 2. Minus 2 plus or minus root of b square. The value of b is 2. 2 square minus 4 into a. The value of a is 1 into the value of c is minus 143 divided by 2 into value of a is 1, which is equal to minus 2 plus or minus root of 2 square is 4 minus 4 into 1, 1 into minus 143. Therefore, minus into plus minus, minus into minus plus 4 into 143. 4 3 is 12, carry 1, 4 4 is 16, 17, 7, carry 1, 4 1 is 4, 572. Divided by 2, which is equal to minus 2 plus or minus root of 4 plus 572, 576 divided by 2, which is equal to minus 2 plus or minus square root of 576 is 24, because 24 ja 576. Therefore, the square root of 576 is 24 divided by 2. So we have two values. That is minus 2 plus 24 by 2, one value, minus 2 minus 24 by 2, another value, which is equal to minus 2 plus 24 is 22, 22 by 2, 11. Minus 2 minus 24 is minus 26, minus 26 by 2, minus 30. You see, since the required numbers is what? Positive odd integers. You take the positive value also. Therefore, x is equal to 11. X plus 2 is equal to 11 plus 2. That is 13. That is, therefore, x is equal to 11 and 13 are the required consecutive positive odd integers. So, x is equal to 11 and 13 are the required consecutive positive odd integers. You can verify. Okay. You see, since the squares of the required numbers are equal to 290. Okay. So you see, you just here you can verify. That is 11 square plus x plus 2 is 13 square. 11 is 121, 11 square is 13 square is 169. That is 0, 9, 290. So therefore, we have done well. Okay. So these x is equal to 11 and 13 are the required consecutive positive odd integers. Thank you.